In this video, we are going to discuss how to find a linear regression line when given a 5-number summary which consists of the average and the standard deviation of two distinct variables as well as their correlation coefficient r. When we're given this information, we know enough to calculate our regression line. We will need the following formulas. Please take a minute to pause the video and write these down if you don't already have them. We will be finding the regression line for the following problem. For women aged 25 through 34 in the Haynes sample, the relationship between height and income can be summarized as follows. The average height is approximately 64 inches, the standard deviation approximately 2.5, the average income approximately $21,000, with a standard deviation of $20,000, and a correlation coefficient of 0.2. Each regression line is in the form y equals mx plus b. M represents our slope and b represents our y-intercept. Therefore, we must first find these values. Our regression line goes through the point of averages. The slope of our line will go up by r times the standard deviation of y for each 1 unit of the SD of x shown in the picture. This is where we get our slope equation. So let's take our problem and plug in our numbers into this slope equation. First, we must determine which variable is x and which variable is y. Y will be whatever we are predicting, so in this case, income is y because we are predicting income from height. So our average for x is going to be 64 inches with a standard deviation of 2.5, and our average for y is going to be $21,000 with a standard deviation of 20,000. Take a moment to write those numbers down so you have them later on in the video to refer to. Thus our slope is going to be 0.2, which is r, times $20,000, the standard deviation of y, divided by 2.5 inches, the standard deviation of x. Thus our slope is $4,000 divided by 2.5 inches, or 1,600, which, being interpreted, is $1,600 per inch. So, theoretically, a woman's income is correlated to going up $1,600 for each inch in their height. Next, we need to find our y-intercept. The equation for this is the average of y minus the average of x times the slope. The averages are given to us in our 5-number summary, and we already found our slope, so we just need to plug in some numbers. $21,000 for the average of y, 64 for the average of x, and 1,600 for our slope. This comes out to be negative 81,400. Now we can form our regression line in the form of y equals the slope times x plus the y-intercept, so it's going to be y equals 1,600 times x minus 81,400, or you can think of it as your income equals 1,600 times your height minus 81,400. To interpret the y-intercept, think of what it means if your x variable equals 0. In this case, x is our height, so if a woman is 0 inches tall, they would make negative $81,400 a year. This idea is called extrapolation, which is determining a value from your regression line that is not within your data set. Obviously, someone isn't going to be 0 inches tall, but in context, this is what your y-intercept is saying. Say now that we are asked to predict how much money a woman would make if she is 72 inches tall. All we have to do is plug in her height into the x value of our equation. So it would be 1,600 times 72 minus 81,400, which comes out to be $33,800. Therefore, we would predict that a woman who is 72 inches tall will make an annual income of $33,800. As a final note, this regression line is showing us that taller women make more money on average because the slope is positive. The taller the woman, the higher their prediction will be on our regression line. However, remember that correlation is not causation. Being tall does not cause you to make more money. It is simply only an association that was found.